Now we will be finding volume of revolution of some selected surfaces. We can use either washer method, disk method, or cylindrical shell method. The examples we are taking in this section all will be with either washer method or cylindrical shell method, and some cases we use both just to verify our answer. First example, region bounded by y equals square root of x and y equals x over 2, and rotation will be about y-axis. So let us take the Desmos graph. Y equals square root of x is the top one, and y equals x over 2 is the bottom one. And rotation will be about y-axis. So since rotation will be on y-axis, so the circles will be formed along y-axis. So you can have a small circle here and a bigger circle here. So that forms the washer. The volume is, we know that pi r squared, and since we have washer, we are getting two circles. One is larger one and the other one is a smaller one. So usually area of a circle or section is pi r squared. Since we have two here, so bigger one minus the smaller one gives you in between. Let us take the radius of the small circle. The equation we have y equals square root of x, so then radius will be x. Since we have a square root of x, we square it, and then we get y squared. And the large circle we have radius rl, and in that case your x is 2y. So now the volume will be now pi, and the limit is 0 to 2 as you see in the graph, and we are taking with y axis, so they say the y coordinates are counted 0 to 2. And you can plug the bigger circle first, larger circle, and then the smaller one, and then your answer will be 64 pi over 15 from the integral. Now we will be using cylindrical shell method for this. So cylindrical shell method is 2 pi and then a to b are h, dx or dy, depends. So we'll see which one works. So rotation about y-axis, and then if we just consider a cylindrical form like this, and the white bar look like this here. So the radius will be r, which is x from here if you consider the point xy, and then height will be, so you can get from the top portion is the square root of x minus the bottom portion is x over 2. So that's the height of the cylinder. And now you are ready to write the volume equation. 2 pi, limit is 0 to 4. The cylinder is moving on x-axis. You can see that the limit goes from 0 to 4. And then we are just writing r, which is x, and then h is this one, so we plug it here and simplify. And as you see here, we are using two different methods, but it's the same problem. Answer should match, and that exactly happened. We take second example. Region bounded by y equals 4x and y equals x to the 3 in the first quadrant, and rotation will be again with respect to y axis. So at the intersection we are writing 4x equals x to the 3, and then you can factor out and solve. You get x equals negative 2, 0 and 2. And since we are going in the first quadrant, we will be taking 0 and 2. Look at the graph here. And now washer method will be same way. So you can take the radius at any reference point. Not necessary you have to go to the graph. You can go somewhere. So if you go from here to the bigger one, and the smaller one will be from here to here. Okay, so we'll determine smaller and bigger. And that gives you radius for the small circle, which is x. So x is y over 4. And then the next one, y equals x to the 3, so then x will be cube root of y. And as you see here, the circles are moving on y-axis. So that's why integration will be with respect to y. So now the volume, we are writing pi, as you know, the larger circle radius is square and the smaller square, and then simplify. Next we'll be doing with cylindrical shell method. So you need to identify all this. Place your cylinder and the cylinder moving on x-axis. So it will be 0 to 2. So you're writing our radius is r, which is x, or any point you consider on this bar. And the height here is, you have the top graph minus the bottom. So that's your height. So then cylindrical shell method, you have the formation. And you simplify, integral as we expect will be same. Number 3. We have now implicit form. X square minus y square is 7 and x equals 4, and rotation will be about the line y equals 10. So you graph this one. So this is the line here, you see. Green line is y equals 10. And x square minus y square is 7. So you have two portions, one here, another we have on the left side. But since x equals 4, enclose it on the right hand side, so the next left side we ignore. And rotation will be about the line y equals 10. And x equals 4 is the vertical line that encloses the area of this here in between, as you see on this. Okay, at the intersection we have x equals 4, so plug it there. Solve for y, which is -3 and +3. So these are the intersections here and at this point. So then we can use cylindrical shell method. This is 2 pi, and the limit you have -3 to +3 RH. And now we need to see what is the radius. So if you want to find the radius from here on this cylindrical shell, so that r will come out as 10 minus y, is that right? Because this is the point here, xy. So you have from x-axis to this is y, so 10 minus y, that's your radius. And then the height will be 4 minus x coordinate of this. And x coordinate you can easily see is giving you square root of 7 plus y squared because of this. So you have x square minus y square equals 7. You can write x square equals 7 plus y squared, and we are taking positive because we are taking the top portion, and it is actually on the right hand side we have taken. So x is positive, you understand. And then plug all this limit and simplify, and you are done for this too.